Okay, so the key pieces of information we're given here are that the price demand function is this here. That means like how much they're going to charge for each item. So it looks like, I think X is the number of cordless drills. So the more cordless drills they're producing, they're charging less per item. Now, if you got 1,000 cordless drills, you want to get rid of them. So you're probably going to sell them cheaper than if you had just like 10 sitting around in the store. So that determines the price, and this determines the cost. If they want the marginal cost function, business marginal cost is talking about a rate of change of cost. So the derivative, we want C prime. That's the marginal cost. I'm trying to think of an interpretation of it. Marginal cost would be like how much your cost increases or decreases based on one increase in products that you produce. And so you just have to take the derivative. Okay? So if you take the derivative of the cost function, you get 65. That's it. That's the marginal cost. It's a constant. It's a constant 65. Every time we produce a new item, our cost goes up by $65. The revenue function, that is determined by the price. This is the price for just one item, right? And revenue, by the way, is all the money a business brings in. So if we sold one item, we plug in 1 in for X, that would be our profit. But what if we sold 2 items? You'd plug in 2 in for X, and that's the price per item. So we'd have to multiply this whole thing by 2, right? Because this is the price for one drill. And we sold 2 items, so we got to multiply it by 2. So if you keep that pattern going, the price is going to be, not the price. The revenue is going to be the price times the amount that we sell. So we don't know how many we're going to sell. We'll call that X. And then we're going to multiply the outside by X because X is the number of items we sell. So this is the price, and this is the number of items. You multiply those two together, and you get your total revenue. So if you distribute that, X, that's 142X minus 0.03X squared. And then just like before, when we're talking in calculus in terms of marginal revenue, we're talking about the derivative of revenue. So you just have to take the derivative of revenue to find your answer here. And then they say R prime of 1,000. So the derivative of revenue at 1,000. So what you do for this problem is you take your answer in for this blank, and you're going to plug in X equals 1,000 into it, and then simplify. And then it says interpret the results. It says at a production level of 1,000 cordless drills, revenue is, I don't know what the drop down is here. At a rate of the absolute value of our, it's probably increasing or decreasing. Okay, so here, I'll go pull up the problem so I can see exactly what that drop down is. Yep, so just check. So you would pick increasing if this X equals 1,000, if you plug that in and it's positive, right? Because that's what a derivative tells you. A derivative tells you how fast something is changing. So in this case, the derivative of R is telling us how fast the revenue is changing. If the derivative is positive, that means revenue is increasing when you plug in 1,000. And if the derivative is negative, that means revenue is going down at X equals 1,000. Okay, so it doesn't tell you what revenue is, it tells you the rate of change of the revenue. Okay, so that depends on your answer for part C. If you plug in 1,000, if you get a positive number, then you should be selecting increase for this spot. And then it says find R prime of $4,200 per drill. That's again, just plug in 4,200. And again, if this value is positive, that means the revenue is increasing. If this value is negative, that means the revenue is starting to go down. Okay. Find the profit and the marginal profit. So that comes from up here. Profit is found by taking the revenue, the amount of money you bring in for your business, subtracted by the cost of the business. So we have our revenue function here. We go in for R of X in that formula. And then our cost function is given here. So to find P of X, the profit, let's see if I can type somewhere. There we go. P of X is going to be the revenue, which we found to be 142x minus 0.03x squared. subtracted by the cost, which is, make sure to use parentheses, 7,600, because you're subtracting everything of what the cost is, not just the first term. And then we got to simplify that a little bit. If you distribute that negative sign in the second parentheses, and then we combine like terms, we got 142x subtracted by 65, that makes 77. And if I put it in terms of descending powers, it's negative 0.03x squared plus 77x minus 76,000. That's our profit function. That's P of x that they want here. And then again, marginal profit would be the derivative of P of x. Right? So if I take the derivative using the rules we studied in the text, we have 0.06x plus 77. And then they want you to repeat what we just did up here. Plug in 1,000 into the derivative. If it's a positive number, then your profit is increasing. If you plug in 1,000, you get a negative number, your profit's decreasing. Okay, and you do the same thing down here.